Hi, this is the fourth little video on the subject of indices, and this time we're going to look at situations where the index is 0 or negative. Now we've got a situation there where 16 is 2 to the 4, we should know that. If we divide both of those by 2, 8 on the top, 2 cubed on the bottom, because we take 1 off the power for dividing. Do it again, we get 4 and 2 squared. Do it again, 2 and 2 to the power of 1. Do it again though. Well, we get 1 at the top, but we get 2 to the power of 0 if we continue our rule about taking 1 off the power. And so we've got this situation where 2 to the 0 appears to be 1. And it is. That's correct. Let's look at some algebra now. If we divide a to the fourth by a, we get a cubed, and then a squared, and then a to the power of 1, or a. Divide it again, we get a to the 0, but a to the 1 divided by a is just simply 1, and so a to the 0 is 1. And that's true as well. Let's look at some examples. Any number to the power of 0 is 1. 17, that expression. Even if it's negative, it becomes positive 1 when you raise it to the power of 0. Even an algebraic expression is 0 because it doesn't matter what a, b, c are. Raising it to the power of 0 is 1. And it doesn't matter how complex the expression is. If you raise the whole thing to the power of 0, the answer is 1. So let's look a bit further than that. That's the sequence we were looking at earlier. Let's divide by another 2. Well, on the top you get a half when you divide 1 by 2. And the bottom you get negative 1 because we're taking 1 more off the power of 2. And so we've got this relationship to 2 to the power of negative 1 or 2 to the power of minus 1 is a half. Let's emphasize that one. Let's do it again. Divided by another 2, we get a quarter and 2 to the minus 2. And that's another correct expression. 2 to the minus 2 is 1 over 2 squared, which is a quarter. And continuing, we would get that result, and etc., etc. So, in general, 2 to the power of a negative number is 1 over 2 to the power of the same positive number. So 2 to the power of minus c is 1 over 2 to the c. And that's worth remembering. Let's do a little bit of algebra on that now. We've seen that sequence before. Divide by another a. On the top we get a to the minus 1. Bottom we get 1 divided by a, etc. And so we've got that relationship. And all these rules are true. Let's just look at those last two. If we take a fraction to the power of minus 1, we're just turning the fraction upside down, or turning it into its reciprocal. And if we've got a fraction like that, to the power of minus 1, it just flips top to the bottom and turns the fraction into its reciprocal. Same there if we raise it to another negative power. So those are the rules to remember for negative powers, negative indices. Let's look at some examples. 17 to the power of minus 1 is just 1/17, a reciprocal. 3 to the power of minus 2 is 1 over 3 to the plus 2, 1 over 3 squared, which is a ninth. 10 to the minus 3, well, that would be 1 over 10 to the 3, which is a thousandth, which in decimal form is that, 0.001. There again, the 3/4 gets turned into its reciprocal by that operation. Here's another example, a fraction, 2/5. If you take that to the power of minus 2, you just turn the 2/5 upside down to make 5 halves, square both parts, so get 25 over 4. And this last one is something that you might have met if you study physics or science, because ms minus 1, well, this tends to be the unit that you use for meters per second. Why? Well, the s minus 1 is just 1 over s, so that becomes m times 1 over s, or m over s, which is meters per second. It's just another way of writing meters per second. And those are negative indices.